machine. Welcome to This Explainer. Okay, let's just jump right into it. We all have this grand sci-fi expectation embedded in our minds, don't we? The dream of just walking into a room and talking effortlessly to a sentient, brilliantly responsive machine. We've seen it in movies for decades. Computers that instantly understand our jokes, catch our tone, and banter back in perfect real time. But well, when we actually open up our laptops or phones today, the reality is a bit different. In this explainer, we're going to look at a fascinating interaction between a user and an AI that perfectly illustrates exactly where we are right now, what the roadblocks are, and what needs to happen to make that sci-fi dream an actual reality.
Our source material actually begins with a highly specific and honestly pretty amusing user request. The user wanted to set the mood for what the AI called a futuristic Friday afternoon in Peoria. Specifically, they were looking at Google anti-gravity concepts, and they wanted the absolute perfect soundtrack. So they asked the AI to play the epic, swelling theme from the movie 2001: A Space Odyssey. It's a totally natural request for a human to make, right? Just asking a companion to put on some music to match the vibe.
Now, the AI's response here is absolutely fascinating because it immediately establishes a really clear boundary. The AI transparently explains that while it can generate completely original tracks, it simply doesn't have a built-in media player to directly stream or play existing audio files through the user's speakers. And more importantly, it explicitly states it cannot function as a music player for copyrighted tracks, like Richard Strauss's famous piece from that movie. It's a fantastic example of ethical transparency in action. The AI is programmed to respect copyright laws, and it manages the user's expectations right out of the gate in a very straightforward, no-nonsense way.
But here's the cool part. The AI doesn't just say a flat no and end the interaction. This brilliantly illustrates how current language models compensate for their limitations. Lacking the ability to play the actual audio file, the AI provides a highly evocative, text-based equivalent instead. It writes out, "A low, vibrating rumble of the cosmos begins. Trumpets slowly rise in the darkness. Done, 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 but dumb. Cue the thunderous, pounding timpani drums." It creatively uses vivid text descriptions to replace the missing audio and set that musical atmosphere. It's a really clever workaround, but it also highlights the gap between what the user actually wanted, which is seamless, real-time multimedia interaction, and the purely text-bound reality we currently navigate.
That text-based workaround triggers a perfectly reasonable frustration from the user. It prompts them to pivot the conversation entirely and ask a really profound question. So, why can't we fluently talk at this point? Why do I only have the choice to talk on a recording or use text? That just doesn't seem right. And honestly, it's the elephant in the room for all of us. Why are we stuck with clunky text prompts or that awkward tap to speak, then wait recording process instead of just having a natural flowing conversation?
Well, the short answer to that frustration is that achieving true conversational fluency isn't just one single technological magic trick. It actually requires a massive, near-perfect sequence of 3 entirely distinct, highly complex processing steps running flawlessly together. And the AI in our source material actually outlines this really well. Let's break down exactly what those 3 critical steps are.
First step is automatic speech recognition, or ASR for short. This is where the AI must take your messy, real-world audio and perfectly transcribe it into clean text. And think about how hard that is. It has to filter out completely random background noise, like a barking dog in the next room or cars passing by outside, just to figure out what words you're actually saying.
Once it has that text, we move to the second step, the brain. This is natural language processing, driven by a large language model. This is the part of the system that actually has to understand the meaning behind that transcribed text, think about the context, and formulate a smart, relevant text response based on its vast training data.
And finally, the last major hurdle is text-to-speech, or TTS. This is the audio output phase. The AI has to take that text response it just generated and convert it back into an audio voice. But it can't just be any voice. It needs to sound natural, expressive, and emotionally appropriate to the conversation.
So the crucial takeaway here isn't just that these 3 mechanical steps exist, but how incredibly fast they have to happen. This brings us to the core bottleneck of the whole system, latency. Latency is the processing delay. Running ASR, the language model, and TTS requires massive amounts of computing power and serious hardware constraints. And here's the thing. If there is even a 1 or 2 second lag while the server processes these steps, the entire illusion of a natural conversation is completely broken. Think about it. A 2-second gap in human conversation feels like an absolute eternity. It causes these highly unnatural gaps that make the interaction feel slow, clumsy, and entirely robotic.
To really get a sense of this, let's starkly contrast the AI's rigid mechanical steps with the incredibly fluid nature of human speech. As humans, our brains process spoken language effortlessly. When you and I are talking, you don't process things in separate sequences. You are subconsciously hearing my words, recognizing the language, understanding the meaning, formulating your own thoughts, and preparing to speak all at the exact same time. Your brain overlaps these processes flawlessly. The AI, right now, is forced to do them largely sequentially. It has to listen, then transcribe, then think, then generate text, then finally convert it to audio.
So to bridge that gap and mimic human fluency, AI hardware doesn't just need to be fast, it needs to be nearly instantaneous. To achieve that true conversational magic and eliminate perceptible delays, all three of those heavy processing steps must be completed in mere milliseconds. Not seconds, milliseconds. We are literally demanding that complex computer networks spanning the globe process data faster than a human brain can even register a pause. The AI in our source material actually provides a fantastic analogy for this. If I were explaining this immense cognitive load to a student using everyday examples, I'd say this. Imagine someone who is naturally a brilliant writer. Forcing them to instantly listen accurately to a question, think on their feet, and expressively speak and answer out loud is kind of like asking them to juggle, do complex math in their head, and sing a song with perfect pitch, all at the exact same time. It's a massive multitasking limitation that current AI is desperately trying to overcome.
Getting all of that off the ground simultaneously requires immense energy. And this multitasking constraint is exactly why we currently experience that tap to speak, then wait phenomenon. The hard truth is, instantaneous audio processing is currently physically and economically constrained by our hardware infrastructure. Running these massive models in real time for millions of users at once means that for now, the system just has to pause, process the data, and then deliver it.
But listen, this is just a temporary bottleneck. Reducing this latency is one of the most active, rapidly advancing research goals in the tech industry right now. Developers are tackling this on multiple fronts. They're working on major improvements in speech recognition to better handle that background noise. They're training more human-like, emotionally resonant TTS voices. And crucially, they are building computationally efficient models that don't require as much hardware power to run. And reducing this latency isn't just about making the AI feel cooler for us. It has a massive economic impact for commercial service providers who desperately need to run these systems efficiently at a global scale.
Because of all that research, the disjointed, text-heavy, wait-for-the-beep experience we have right now is not a permanent state of affairs. It is merely a reflection of exactly where the technology happens to stand today. We are actively moving toward a goal where all of those complex processing steps happen invisibly. As we get faster hardware and better algorithms, daily AI conversational quality is going to absolutely skyrocket. A truly fluent, real-time conversation between you and an AI, where it feels just like talking to a friend, is visibly on the horizon.
Which brings us to a final, pretty provocative thought to leave you with today. We know what the technical hurdles of speech recognition, language processing, and audio output are. We understand the latency and hardware constraints. But we also know those hurdles are being cleared at breakneck speed. So when AI processing finally catches up to human fluency, when that delay drops to zero, and you can interrupt, banter, and converse totally seamlessly, how will instant, lifelike conversations change our relationship with machines forever? When they start sounding and reacting exactly like us, how will that change the way you live your daily life? Think about that for a while. Thank you so much for joining me for this explainer, and keep questioning the technology around you.